All right, welcome to our first video on our graded activities, which is sea level presentation. So we're going to do the part that is going to set you up for the part that you're going to do. So we're starting off with this first one. It can be found in week 1. And so let's go ahead and get right into it. Boom. And let's go ahead and minimize this right here. So first things first. What is a milliliter? Well, a milliliter, if you look at a ruler, right, this is 1 centimeter right here. A milliliter is this little tiny line in between. So you can see that millimeters are really small, right? 2 centimeter is 1 inch. So 2.5 centimeters. So this right here is, oops, let me go ahead and draw that through. Right there is basically 1 inch. Just to give you perspective, that way you know when we're talking about millimeters, you'll have an idea, at least in your mind, of how much that is. All right, so this would be 1 inch right here. So we took some data on the internet from the NASA website, and I started on the year 2000 to 2005, and we ideally want to make predictions in the future. So this is sea level rise in millimeters. Now, what that means is the sea level, right, or ocean, is rising every year. The question is, how much is it rising by? Well, this is according to the data, right? 21.8. That's how much it has risen up to this point in 2000. Obviously, 2001, it rose 23.8, then 28, and then 33, 36, and 39. So the question, the very first question here is, does the sea level rise at a constant rate? Well, in this particular problem, the sea level rise does not grow at a constant rate. So I'm going to go ahead and get my typewriter real quick here. Let me go ahead and get my typewriter. So the sea level rise is not at a constant rate. Okay, because let's go ahead and we want to justify this, right? Because, well, why does it not grow at a constant rate? Well, I want you to take a moment to look at this right here. How much does it grow to get from here to here, right? Well, 21.8 plus what gives you 23.8? Well, in this case, it's 2, right? 21.8 plus 2 is 23.8. Well, what about down here? Well, now it's starting to get a little bit harder to do in our heads, right? So you might want to go ahead and open up our Google calculator. So there it is right here. And the way that we can figure this out is just to do 28.2 subtracted by 23.8. So 28.2 subtracted by 23.8. Boom, and we get 4.4. So we know 23.8 plus 4.4. Let's go ahead and roll it in right here. Boom. Is going to give me that. Now, how about the next one, right? Well, this plus that will give me this right here. So let's go to 33.4 minus 28.2. So 33.4 minus, did I get that right? There it is, 28.2. Okay. And we get 5.2. So you can see this is 5.2 right here. Boom. Okay. So now we just take a look at this right here. It does not grow at a constant rate because every year, so let me go ahead and get the top writer real quick and let me explain it. First of all, I guess to tell you is, what is a constant rate? Well, in order to be a constant rate, you need to either add or subtract by the same amount. So in order for this to have been constant rate, let me go ahead and we're going to change our color real quick. We would need this to be plus 2, plus 2, plus 2 every time. Every time you go down, it should be adding by 2. That would be constant rate. But in this case, it is not constant rate because, and now we can go ahead and write this out, because every time because every row is adding a different number. Okay, there it is. And let's go ahead and just make this a little bit, hold on, hold your snoggin. Okay. Well, maybe we need to lower this down in size. That's probably what I need to do here. Let's go ahead and do this. There it is. Okay. So the sea level rise is not at a constant rate because every row is adding a different number, right, to our sea level rise. Now, it makes sense that it's not adding by the same amount every time, because this is real data. Like, this came from NASA, so that's officially real data. So what do you notice about the trend in sea level rise in millimeters from the year 2000 to 2005? Well, it's increasing, right? We know that this is increasing because the numbers are going up, and so that means that the oceans is rising more, right? That means that the ocean is kind of like getting bigger in a way. So ocean getting, you know, bigger. Obviously, I'm just gonna write this here. Don't worry about that. Boom. What are some potential issues with the sea level rising too fast or too much? Well, what you can do is go to Google and go to sea level rise problems. And you can go ahead and watch this video, or you can read this article, or 5 terrifying impacts of sea level, rising sea level. So you can just type that in there, and you can go ahead and watch one of those, and you can fill that out yourself. There's a lot of issues potentially at hand here, but I'd rather you do that research. So your job is going to be to fill this part out right here, because that's what was you were in charge of in class. All right. So we want to make some predictions for the future sea level rise. While it's not the exact data, let's try to change it up a bit so that we can do some modeling. So for example, right, you're going to notice over here that, you know, this is 2, 4, 5. This is roughly what? 28, 29, 30, 31, 32, 33. So 28, yeah, so about 5-ish, right? I'm going to just write 5-ish. And then here is about, you know, 3-ish. And then here's about, you know, 3-ish, right? Because 33 plus 5, sorry, hold on real quick. 33 plus 3, what am I doing here? I was doing the one up over there. 33 plus 3 is this. This plus this is this-ish, right? So you can see these ones are going by 3. This was 2, 4, 5. So we want to model this. We want to get a constant growth rate. And we need it to be adding by the same amount every single time. So what I did is, in this case, I chose 21. I chose it by accident. I honestly should have rounded up, and I should have done 22, because I think the data would be more accurate. So when you go to do this, you're going to do 22. So obviously you're seeing me. It's still going to be okay. Obviously I'm doing a mistake because I started at 21 and I felt like that didn't round right. And what I did is I added by 3 every time. So 21 plus 3 is 24, right? 22 to 3, 24. 24 plus 3 is 27. And then I added 3. And you can see that, why does it make sense to have a constant rate be 3 and not 10? Well, the data, we want the data to match, right? We want this data to be close to these numbers. So you can see that we're pretty close to it, you know, maybe a little underestimated, but that's okay. And at least we are in the general ballpark. You know, maybe we could do 3, 4, or 5, but 10 is too big, right? Because the data is not adding by 10 or even close to it. So now that we did this, there's a reason why we wanted to model, to make models. In order to make models, oh my gosh, I can't speak. In order to make a linear equation, we need a constant rate of growth, right? We need it to increase by the same amount every time. So let's go ahead and, so, you know, obviously we filled that out. What is the equation of the table? Well, y is equal to, well, what is our starting value? Now, when I do starting values and I make equation, remember, your equations will always come from the y values. That's just something that is true in every single scenario. This is our years. Right? Obviously the years stay the same, 2000, 2001, 2002, 2003. What we care about is the sea level rise. So what is my starting value? In this case, my starting value has to be 21, because that is when we started in the year 2000. And then now what's the pattern? Well, this is why we needed a constant rate of change. The pattern is that we're adding by 3 every time we go down this table. So naturally you can just do plus 3x. Boom, like that. And then that's going to go ahead and help us figure out how we can get our data, right? That's going to be our data. Now, how does this work out and why does it make sense? Well, you know, we're starting with 21 and then we're adding by 3 every time, right? So you can notice how in this case, if I want to get to 27, I need to add it twice. Well, if I plug in the 2 into here, 3 times 2, that's 6. That's what we get with these 2 right here. So now the question is, what is the sea level rise in 2020? Well, now that we have our equation, we can do some modeling. 21 plus 3 parentheses. And a very common mistake is to go ahead and put 2020 right here. And we don't want to put 2020 because remember, we started, this 21 came from the year 2000. Let me go ahead and say this real quick. It's kind of bothering me how my pencil tool is looking a little glitchy, if you would say. Let's hope that it got a little bit better now. Ugh, I kind of hate how that looks, but okay. This is the year 2000. So from the year 2000, oh my gosh, from the year 2000, and I think I know what the issue is. Here it is. Let's see if that fixes it. To the year 2021, 20, it's been 20 years. So you want to put 20 into here, right? Because that's the difference between these two. So now that we did this, we're going to get y is equal to 21. Oh my God, that's bothering me so much. Let's try this real quick. Let's try this. Why does it look so glitchy? All right, here it is. Plus 60. And then we're going to get y is equal to 81 millimeters. So you can see right here, according to our data, by 2021, 2020, I keep saying 21 because we're about to be in 21. According to our data, in 2020, it should be at 81 millimeters, right? Well, hold on real quick because I want to show you something. So here is the sea level rise according to NASA. Let's go ahead and go to 2020. And you can see that even just by me toggling around, February 9th, hold on. I had to sneeze there. February 9th, 2020, it was 92.3. So you can see that we have about, our latest measure actually right here is 95. So you can see 92, 95 is the actual sea level rise. You can see that we were under, right? We were an under representation. Boom. So that's not good. Our numbers was lower. So what you want to do is you want to come up with your own constant rate that you think is going to give you a better estimate. Again, the real number, I'll just write it over here, was roughly like 92 millimeters. I don't know why it's so glitched out for. I might need to reset my computer, which I'll do maybe this next one there. So sorry, it's kind of glitchy, but 92 is the real one. So you need to pick a constant growth rate that you're going to add by that's going to give you a better estimate. And then you're going to answer these questions down below here. So now that is what you're in charge of. That was our first graded assignment. So you should be set up now for you to go ahead and finish this activity.